Hello everyone, this is Singh 𝐿 and I am back with another video in which we will be discussing how do you design systems where scheduling is important or where you are scheduling some task to be executed at later point of time. And one such example is you schedule a LinkedIn post or you schedule a Instagram post that is posted at particular time in future. So let's say you written hello everyone, system design on AWS is out, and let's say this is out on some date, so you schedule this post at that particular date. That date has already been passed because the book is already out, but let's say you are writing something that this book free trial is available, and you are posting this notification tomorrow at 10 p.m. So you can schedule this post now so that it is posted at a later point of time. Okay, and this is very useful. This is very useful in a scenario that you don't have to be online at that point of time, so you can schedule your any of the task. Okay, so this is one of the examples from the social media platforms, like you are scheduling some post or writing some threads which are posted at a later point of time. This is very well true in case of batch workloads. Okay, you run your workloads or you schedule your workloads as a particular time. So there are two scenarios, there are two requirements. Basically we will discussing one, but what are the two requirements? One is you schedule you schedule a post or a job at later point of time. Second is recurrence. Okay, so you schedule it once, but you also want to recur or re-execute this job at regular intervals, let's say each hour or at every Sunday at 1 p.m. Okay, so these are the two requirements when we look around the systems, or like we try to design the systems around job scheduler. If you search on the internet, you will find these description around designing systems distributed job scheduler, basically. Okay, so distributed, you it don't have to be distributed, but if you want to be if you want that it has to be distributed, then you can create it as distributed. But the idea is it a multi-tenant system where multiple systems can come in, onboard their use cases, and then schedule their jobs. The job could be whatever it is. Okay, so this is the description of what we are discussing today. But before we move into more details, we have to do two things as we do always. First thing is you have to subscribe to the channel, the awesome great channel MsDeep Singh, in which we talk about system design of different systems. Okay, so you try to understand, you learn system design concepts. We talk about AWS services, we talk about cloud, we talk about diving deep into different large scale systems which are built by the companies. Okay, so there are a lot of details you will find. Take a look at the channel MsDeep Singh and you will not regret. The first thing is done. Second thing is system design on AWS. What is system design on AWS? System design on AWS is a book in partnership with O'Reilly. So if you, even if you don't trust me, you can trust the O'Reilly brand. So the system design on AWS is a great book which talks about system design concepts. So there are different concepts you should learn or you should understand. Basically, when I say learn, you should understand basically, so that you can make better system design decisions. So concepts is one thing. So that's the first part of the book. Part 2, this is P1. Part 2 talks about AWS services. Okay, so there are different AWS services. Let's talk about one example. Let's say in case of compute, so chapter 11 is focused on compute. Okay, in compute you have EC2, you have ECS, you have EKS, you have Lambda. Okay, so there are multiple options on which the way compute basically means how you deploy your application, the server. Okay, so there are different ways you can deploy the application. What are these options? Basically, first of all, you have to understand what are these options, and then you have to understand, then you have to decide, or you have to make a decision that which one is the best for you. Okay, so this is all about part 2. There are different AWS services which are being discussed, and on which use cases you should use the particular AWS service. Part 3 talks about actually building of systems. So now you have systems and concepts, you have understood the AWS services, now you can actually build the system. So it has 8 chapters, 8 great detailed dive deep chapters which talks about actual building of systems. One such use cases, let's say you are want to build chat application. Okay, so chapter 19 is the chat application. Then you have hotel reservation system. Chapter 18 is hotel reservation. Chapter 16 is social media platform newsfeed building. So there are a lot of insights you will find in the book in AWS. First you will learn concepts, then you will learn AWS services, and then you will actually build the system. So consider looking into the book. You can get a free trial on O'Reilly, and then you can explore the book. Just check out the table of contents. You will not regret. It is written by Jayant Kumar and Mandeep Singh. Mandeep Singh is the person who is speaking right now. Jayant is the co-author of book. Okay, so consider taking a look. So we are done with the two things. You have to take a look at channel MsDeep Singh. I'm not saying you have to subscribe and subscribe. Just take a look and then you can decide for yourself. And then take a look at the book system design on AWS. It's available on O'Reilly as well as Amazon. And in India, you can buy it on Soft Publishers as well, which is the local publisher to buy the book in Indian subcontinent. Now coming back to our discussion, which is LinkedIn post scheduler, distributed job scheduler, whichever scheduler which you are trying to do, we are trying to design a job scheduler. So what are the functional requirements? We already discussed, we already mentioned that you want to schedule a job, right, or recurrence, or sometime once in the future. But let's discuss the functional requirements clearly, because whatever system you are designing, first you have to understand the requirements well. And there is one critical thing, or like one important thing, not critical, one important thing about this discussion today is that we will not go into much about like how the system looks like, but we will try to understand what are the different ideas. Okay, what are the different ideas which you can use to design the systems, and just use those ideas to make your system, or like create a system design diagram, high level diagram from using those ideas, and then comment it out. Okay, then we will see who is the person who is coming up with the best design depending on the requirements. There is no such thing as best, but yeah, well, let's see. So what are the functional requirements? Allow, yeah, and this discussion is based on LinkedIn post schedule. That's the heading as well. Allow users to create a post and schedule it for later. This is our basic requirement. Users create a post and then it is scheduled to be posted later, or it is made live at a later point of time in future. First thing clear, delete the post and remove from scheduling this. So you basically have to support all the CRUD operations on scheduling. Okay, you can create the post. Okay, you can modify the schedule, you can modify the schedule, you can create the schedule, you can modify the schedule, or you can delete. In modify, you everything comes up. Okay, you can delete, you can edit, all those things you can do. Edit or post or edit the schedule. You can also edit the post, which is content inside this post which is being scheduled. So you can do all those things. These are the functional requirements for our system. Now when I talk about LinkedIn post schedule, we will focus on the scheduling part, not the post creation part. Okay, you can assume that there is a separate post service which handles all these things. Okay, we are not touching up that service. It's the scheduler, it's the scheduler which we are going to talk about, which takes the responsibility to invoke this post service to make that post live. Such as this post service believes that this post came up right now and I have to make it live. So nothing is changing for post service. It's just an additional component which you are introducing in your system. If you talk about in very simple terms, what are the NFR, non-functional requirements? What kind of NFR we are looking at when we are designing the system which is scheduling of LinkedIn posts? First thing, is the post published exactly at the same time the post is scheduled? How much delay is allowed? Latency basically. Okay, what's the latency, what is the delay you can expect? Okay, so let's say the post is scheduled at 10:00 p.m. So is it okay if it made live at 10:01 p.m.? Is it okay? It's kind of okay. Okay, we try to strive that the post is made live in the seconds of difference. Okay, but even if in some scenarios it is made live at 10:01, then it's fine. Okay, so that's the delay. We are trying to strive to build a system whose latency is less than 60 seconds per se, so it's do not go to 01. But even if it goes in some of the scenarios, we will definitely want to take a look at what are those scenarios. But if it goes, then okay, we are fine. We will what you say, we will overweigh our availability over such scenarios. Okay, so availability is more favored in contrast to the latency. Scalability, we definitely need all these things, okay? Scalability, availability, and extensibility. Why? Scalability, because right now this feature is used by less users or less services internally. It can be later used by multiple users as well, okay? So there are some external users which are using to schedule the post. There are internal services which you are using this scheduler service to schedule their workloads, any workloads they want to do. The system should be available to for the users to schedule the post. And then yeah, extensibility, as I mentioned, the system should be multi-tenant, and this is very well discussed in our book System Design on AWS. What multi-tenant system is, it's basically, and we have also created the videos on our channel as well which talks about such use cases. Multi-tenant basically means the systems can come and onboard to a system and it works out of box for them. You don't have to write separate application code for each and every use case, okay? So let's say you have created this scheduler. This should work for scheduling the posts, okay? Scheduling some internal jobs, let's say Spark jobs, scheduling something else. So schedule is our use case and this service should be able to fulfill that use case. Let's clean this up and make our book again beautiful, okay? So the cover page is great and the forward is written by Swami, the AI guy from Amazon, okay? So you can, again, you have multiple names to trust the book or the content which is written in the book. Now scale, no numbers I have mentioned here, but you can assume that yeah, we have a high scale that we have to support on a LinkedIn level. Coming back to the design, not back, we haven't started. So starting with the design, this is not coming back, this is starting with the design. Let's change our pen to the more user friendly, more reader friendly, more viewer friendly design. So starting with the design. Now what are the components that we want to discuss? So when I say schedule, right, how you think around this use case, so it's simple. Assume it this way, right? Let's say this is your handsome user Mandeep, okay? Mandeep is always handsome, so we always mention that yeah, Mandeep is handsome user Mandeep, okay? Mandeep is scheduling post that this book System Design on AWS is live and then you can go buy it, okay? So this post is scheduled for, let's say what's the date, 1 April. Today is not 1 April, but yeah, uh, 1 April 10:30 a.m. I generally schedule my posts at 10:30 a.m. and I heavily use this feature. I generally create all my posts over the weekend and then schedule it for like the entire week, okay? So you are scheduling this post for 1 April 10:30 a.m. Now this post, you have to store the schedule somewhere, okay? This is your DB, so you have stored this schedule in this DB, and then uh, what you have to make sure that once this schedule comes up, okay, so at 1 April 10:30 a.m. you have to call the post service that make this post live. This post is created by handsome user Mandeep. Mandeep handle is MsDeep14 on the LinkedIn if you haven't checked it out, and it's also shared in the video description, so you can connect with me or LinkedIn. And you can also use to schedule your post if you are not using LinkedIn. So this post should be sent to the post service to made it live at this particular time, okay? So this is our use case. So what you are doing, you are storing the job schedule into the database, and what you are doing, you are polling every minute to check if there are any jobs for execution, basically if there are any jobs which has to be sent to the post service, okay? Now this 1 minute can be dependent on the use case, right? So in case of LinkedIn, you can schedule it post at interval of 15 seconds. So you can schedule the post at 10 p.m, then you can schedule the post at 10:15 p.m, then 10:30 p.m, okay, just to simplify the design. And we should definitely use this feature, okay? We should definitely use this kind of what you say implementation in our use case as well, because it simplifies our design, okay? It simplifies our design. So this is how you can do it, and you can also do it for batch workload because it's nothing real time, okay? It's nothing real time. It works on an offline basis. So you can say let's poll every 15 minutes, to check if there are any available jobs for execution. So this checks this DB every 15 minutes, and if there are any jobs which has to be if there are any post which has to be made online, then this calls this what is this scheduler component module or something service, anything, it's a module, like okay, it's the module which takes on the user request, and then the post or the request is sent to the post service for the post to be made live. Now what are the drawbacks with this approach? The problem with this approach is, first thing is, you are polling it every 15 time. Okay, that can be fine depending on how much data it has. Okay, so if the data grows over time, okay, data grows over time, as in, like, let's say 10 million users are scheduling the post every minute. Okay, so you have those 10 million posts, and then you have to query the entire table. You have to query the entire table that, yeah, these are the users which are not, these are the posts which has to be made live. Even if there are not post has to be made live, this table has to be queried in total, that, yeah, if it matches our description. Okay, what's the description, that what are the posts which has to be made live right now. So if I am checking at 10:30, this will check, it will go, let's say there is one post at 10:30, there is 1:30 at one post at 11, then 11:30, then again 10:30. So this query should filter out these two posts. Okay, but it is going through this entire table. You can definitely create indexes and all, but it's a tricky situation when it comes to the time period. Okay, it becomes hard because you're operating on the time frame. We'll discuss that again, how you can improve that. But yeah, querying the huge table is not a good idea, even though queries are paginated, definitely, because you are querying the lot of data. There can be redundant lookups every time. Why redundant? Because yeah, this is not the data you want to look it up, because these posts are has to be scheduled in the future. These are the only posts which you are looking right now, so there are redundant lookups every time. What are the improvements? Let's talk about the improvements in the idea we have discussed right now. First thing is, you can create the logical partitions in the database depending on the time frame. So these logical partitions, you can read it on the internet. This is supported by most of the relational databases. uh, the idea is pretty simple. Okay, the idea is, and logical partitions, and you can also create the partitions in case of, let's say, DynamoDB as well. Okay, so you can create your partition key depending in such that you have logical partitions in place. Okay, so you create logical partitions in your database, and then you query the specific partitions only. Okay, now when I say logical partitions, what do I mean? It means, let's say your partition key is time frame, okay, underscore some key, some random identifier. Okay, so your time frame is, let's say, your DDDDMY 1 April 2025, and then your time frame is 10:30, and some random identifier you can't have, because it will be hard to know which identifier you are looking at. So you just query this particular partition at that point of time, and then check at that point what are the databases, what are the posts that has to be scheduled at that point of time. So that's great. So you can create your logical partitions accordingly, and then you can query at that point of time. Automatic removal of partitions after the query, this is the optimization you can do that once the post execution is successful. Okay, so once you have sent the query to the post service, what you can do, you can remove the entire partition from the database, so that you don't have any redundant data placed on the scheduler component, because you don't need that basically. Or you can push it to your archival if it's needed for the future use cases. Another thing is, you can divide this polling into multiple parts. Okay, you can divide this polling into multiple parts. Okay, so first thing was that you have created the different partitions. Now again, the data in the partitions can be really huge. Okay, again, you might need further partitioning. You have earlier, let's say, created this turn 15-minute partition, but this can be also used. You might need to have a further partition in place. Okay, so what you can basically do is, you can create a partition such that they can be polled by multiple instances. Okay, because in the end you have to poll the data up, and then you have to also call this post service for the execution, for this execution. So you can divide the polling into multiple parts, and this uh, this is implemented by one of the companies, I don't remember one, and it is also shared on their engineering blog. The idea is that there are multiple ports in your service, if your deployment is Kubernetes, okay, or task in case of ECS, elastic container service, or instances or servers in case of just EC2 deployment. Okay, the idea is that you assign a particular ID to each port whenever it comes up, and then it queries that particular subset or particular partition of the database, and it continuously polls for the data, for which query, or like for which use, not use case, not query, for which subset of users the post has to be made live right now. And the way it is done is there are separate ports, and whenever it comes online, you have a coordinator in place. This coordinator assigns a identifier, and based on that identifier they go into the database and then queries for the data, goes to database and then queries the data, and then run that, what it runs, it goes to a post service that schedule this post and then execute it. This is what we discussed right now. How will the instance know how, which segment of data needs to be pulled? You need a coordinator which assigns a segment to the service instance. Coordinator such as zookeeper, okay, you can use any coordinator which is responsible in managing all these instances, and then assign the particular identifier to them. Service instance of scheduling service pulls the segment and checks for the data. And you also need a coordinator, because everything we are talking about right now was that you have a single instance, right? But you, if you have multiple instances, you can't have a single instance, right? If you're talking about multiple scale, huge scale, there are horizontal scaling in place. So your application, this scheduler component, is deployed on multiple instances, so you have to ensure that the data you are pulling from that coordinator is not executed, data which is being pulled by the service instance, not coordinator, my mistake, service instance is not executed by multiple instances at the same time. So it checks for the data. So you have assigned a particular partition of data to a particular instance, so you can be sure that that particular subset of data in the database will not be accessed by the another Kubernetes pod or service instance. The scheduling service push the event to queue, and its user post service responsibility to consume the event. So here we directly talked about that, this uh, scheduler component pushes this to calls post service. But a simplified approach could be, like a more favorable approach could be, that it push the events into the queue, that these post has to be made live, and depending on the availability or like whatever traffic the post service can serve, it pulls up the data from the queue and then reads it, and then schedule, or not schedule, just make those posts live. Okay, upon successful consumption, the event is deleted from the queue and DB is updated with the success status. So it's basically your state machine, that earlier it was scheduled, then it was sent and then executed, and then finally once this is acknowledgement is received from the post service, it is also marked as success, that this post is successfully posted, and it can be then later on deleted or moved to archival in the scheduler component. Custom handling. So the here the retry strategy on follow, you also need some kind of retry, right? What if this something here fails? Okay, something here fails. So what you need here is that you have a retry mechanism in place. If something goes wrong, then you retry that, yeah, this post was not executed once, and you also have to ensure that your event is only pulled once from this queue. Okay, so you have to have the exactly once delivery in place. Either you are using SQS or you are using Kafka. Okay, you have to ensure that a single instance is pulling the data from here, and then trying to make that post live. There should not be two posts which are made live at the same moment from the same user. That breaks our user experience. So this is one of the approach which you can use. Let's talk about other ideas as well. Okay, I mentioned, not we mentioned, no, there is no we here. So I mentioned that there are ideas that we will be discussing today, and then you can come up with the system design diagram which can be used to design the system. So what are the another approaches? First approach is you can use the TTL feature of data stores such as Redis and DynamoDB. Okay, what do I mean by this? Okay, so you have a database. Okay, you have a database. This is your DB. This is your database. Okay, you have multiple entries, 1030, 1130, then you have 230, then you have 1030. So when I say TTL feature, what do I mean is that whenever TTL basically means time to live. Okay, if you haven't heard of what does TTL mean, it means time to live. Now when I say TTL, it means that once the time has come, okay, so if let's say the current time is 10:30, if I have set the entry, if the set TTL for this particular row as 10:30, this event or this row will be deleted from here at 10:30. Okay, now this can be dependent on the database to database. Okay, this can be dependent on database to database, that is it exactly deleted 10:30 or at some later point of time. Generally this works in batches, and you do not delete it exactly at the same time, and then there can be delay because they run in batches and in the background. So it's a background process which runs. But the idea is, you can try to use this TTL feature, that this event is deleted. Now you know that whenever this event is deleted, it publishes the event. Okay, so you can consume that event and then know that yeah, this event is deleted. So why it is deleted? Because the time has come to make this post live. So you can go to post service or like push to that queue which post service maintains, and then this post is pushed here, and then this post service can make this post live. So this is the idea when I say TTL feature can be used here. Whenever entry is deleted, delete event is consumed, which we already discussed. Custom handling, which we already discussed, that there can be there is a possibility that the event is not deleted at the exact same time. So you need a custom handling in place to free fetch the events and handle them accordingly. So instead of deleting this event as 9:30, you can delete this event, let's say at what do you say, 5:30. Okay, so you have that 5 hour buffer window in which you can continuously poll, or you can use any other mechanisms, so that you basically prefetch the events and then you can handle them. You can, one of the mechanisms could be by pushing this event to SQS and continuously polling at an interval of 15 minutes, which is the maximum allowed time. So this is one of the use case, and this is highly dependent on the database. Okay, so DynamoDB, Redis, these are the two databases that I know that you can push the event, push the data entry, and then you can use the TTL feature, so that whenever a TTL expires, you get that event, and then you can use that event to push the post to post service. Additional consideration: post should be scheduled only once. This we already discussed. Exactly once delivery, we need failure handling. This we also discussed. Any component which is added here, we need proper mechanisms of failure handling as well as proper observability in place, so that if anything goes wrong, we are able to identify it and then rectify it. Event Breeze is one of the service which is used by, which can be used for scheduling, but we were talking about the generic design which can be used. So this is all in the discussion of today's video. If you are convinced that yeah, I'm a great teacher which explains the system design concepts well, then consider subscribing to our channel MsDeep Singh, and then also you definitely have to check out the book System Design on AWS. We will meet again. Till then, stay safe. Tata. Bye bye.